Okay, molarity. Let's talk about molarity. Molarity basically a little brighter, hopefully. Molarity is a way of trying to identify or give uh, quantitatively give significance to a certain concentration. In other words, when you have Bill Miller's tea and you get the sweet tea, their sweet tea doesn't mean that it's going to be as sweet or sweeter or less sweeter than anybody else's tea. There's no way that you know. You know it's sweet tea and you know it's got sugar in it, but you don't know anything else, right? So we can't, you can taste it and you could tell them, well, I want half and half, so it's not as sweet, or you could add more sugar because you want it sweeter. But we can't do that in chemistry. We can't go tasting solutions or anything else. Okay, it's not good for us. So we need to be able to identify how concentrated, how strong or weak or dilute a solution is going to be. And we do that with molarity. And molarity has units. We use a capital M. So anytime you see a capital M behind something, that means molarity. Calvin, put your phone away in your pocket somewhere. And so all we're doing right now is being able to figure out a way to identify that concentration. So in molarity, the equation is molarity equals moles over liters. And so every time we do a problem, if you would just write it and rewrite it in the algebraic form that's in, eventually it's going to be easier for you to remember what to do. That's just the way that your brain works. So let's kind of go through our some examples on how to do that, and I'll let you work on your own. What is the concentration? Again, we're going to underline what we need to know. In a solution prepared by dissolving 17 or 11.7 grams to give 230 milliliters. So we have three variables: molarity, moles, and liters. They have to give you two of them somehow. So this is what I'm trying to find. These two are what given to me. So a lot of times we're going to start doing this in a little different format. If I know I need these three things, I'm going to write them down the side so that I can start pulling that information out. So molarity, this is what I'm trying to find. So I'm just going to put a question mark there so I know that's what I'm trying to find. I'm trying to get you away from reading the word problem over and over and over again, trying to figure out what to do. Okay, pull that information out, then you don't have to read the word problem anymore. Moles. Did they give us moles at either spot? No. But is there something they gave us that we could change into moles? Grams. So again, I want to pull out, oops, I can't even write. I want to pull that out and recognize that I have to change it into moles, okay? Trying to let my brain work a little bit easier. I'll pull the information out. And then liters, it didn't give me liters, but it gave me milliliters. So once I have that information out, there's no reason for me to have to go back and read that problem over and over and over again. And that's what I want you to do. That's how to solve any word problem. When you get to physics, the same way. Pull your information out. Because you can read some of that stuff in physics 10 times, and it's not going to tell you what to do. Okay, we're going to try to start recognizing. So I put this column just because this is what I'm going to change it into. Well, I'm still looking for this. But now I need to change grams into moles. And we've done that like we'll do that like we've always done that. Take my 11.7 grams, and it happens to be CH3OH. Okay, I know it's a little tough to see. So, and I'm changing it into moles. So if moles up here, grams is up here, grams drop down below. A 1 always goes in front of a mole. And then we get this number from the molar mass on the periodic table. So yes, you're going to have to start getting your periodic tables out again. We have 1 carbon, 4 hydrogens, and 1 oxygen. So if somebody on their calculator take 1.008 times 4, that would take care of the hydrogen, plus 15.999 would take care of the oxygen, plus 12.011 would take care of the carbon. And what do we get for a total then? 30 what? 32.04 grams. Okay? I mean, after stoichiometry, this stuff is probably a lot easier, right? Hopefully. And we do that, 11.7 divided by 32.04 times 1, what do we get? 0 point something. 0.36. We have three numbers. Can I have, what else? 365 moles. Just trying to work with significant figures a little bit. So I'm going to go ahead and put that now, 0.365 moles. So I know that I've got 2 of the 3 done. And then, yes, ma'am. There's only 3 hydrogen. Oh, and never mind. Yeah, just FYI, that OH, the reason they separate that out, the OH at the end means it's an alcohol. So if you get into organic chemistry, OH at the end tells you it's an alcohol. They have amines, carboxylic acids. There's different ways that they write the formulas to help us recognize that. So, and then let's convert our milliliters to liters. We had 230 milliliters, and we want to change that to liters. So milliliters are up here, milliliters go down here. We can use this conversion chart, the T-chart, for any kind of conversion. Okay? How many milliliters are in 1 liter? Add another 0. 1,000. 1 liter is 1,000 milliliters. We divide going down, that becomes 0.230 liters. So right there, and now I've got everything I need. I have it in moles, I have it in liters. All I have to do now is just plug it into the formula. So molarity equals moles, over liters. So molarity equals, what do we have? 0.365 moles over 0.230 liters, which then equals, okay, 1.58. Somewhere I had 1.59. I might have just carried another significant figure. Somewhere close to that is fine. So again, it's a process, but it's a process of just digging out what we have and changing it into what we need and putting it into a formula. You don't have to memorize this formula. This formula is given to you on our blue star chart. Okay, almost all of chemistry, we haven't had to memorize too many things. Questions on that one? Okay, let's go to the second one. I'll try to zoom in a little bit so help some of you see in the back. There are blank moles, so this is what I'm looking for, in 0.5 liters of a 0.3 molar solution. So hopefully I'm going to start recognizing moles, liters, big M for molarity. So I'm going to use that formula. Let's pull our information out. They gave us the molarity. What is it? It's 0, thank you, 0.300. They gave me my liters, and they asked me to find the moles. And at the top of your chart up here, there's a triangle. Okay, and I always recommend using the triangle, even if you're pretty good at rearranging algebraic expressions. It just makes things a little bit easier. So if you remember using the triangle, you can do it for any kind of fraction in an equation. It's moles over liters. So that means the big M has to go down here. I know it's written up there, but I want you to go through the process of doing that. So if I'm trying to find moles, all I have to do is cover up moles, and it's going to be what? You're going to multiply those two things. So it's going to be big M times big L, liters. And all I have to do is, again, it really does help you to write this, and then write this. Just helps you to remember. If you were to do that every time when it comes time for the test, your life is just so much easier. So my big M was 0.3, and my big L is 0.5. So the number of moles I have is, thank you, 0.150 moles. Okay. I know we tend not to want to write everything out, but I'm just telling you, once you would start doing that, your life becomes so much simpler, and you'll get done. Actually, a lot of times you'll get done faster. And you don't make mistakes and have to go back and make changes. Okay, so the first example, they gave us grams, right? This time they're asking us to find grams. So how many grams? Let's see, we'll change it up here. How many grams are in 175 milliliters of a 3.5 molar solution? Slide this up a little bit so you can see. So let's pull out our information. Did they give us the molarity? Yes. 3.5 molar. Did they give us moles? No. So I need, but they gave me what? Oh yeah, I'm sorry. They're asking me to find grams, right? So I'm going to actually have to take moles and change it into grams this time instead of vice versa. And then they gave me 175 milliliters, so again I'm going to have to change milliliters to liters. Put a little question mark there because I'm looking for the grams. So I can carry this one over, 3.5. Let's go ahead and do the easy one. Let's find our milliliters. Find our liters. 175 milliliters. We want to find liters. Milliliters are on the bottom. 1 liter is 1,000 milliliters. That's it. You ought to just memorize that because we're going to use it off and on throughout the rest of the year. It's just one of those simple things. So this becomes 0.175. Good. So I'm going to write that in here. And I have to recognize then that I need that third box. Well, I can't find grams until I find moles. So again, I'm going to, again, repetition. Do it over and over again. Takes me all of about 5-6 seconds to write that out. Another way you can do that, if you don't like writing this formula up, why don't we do this? Why can't we just take that triangle now and plug in the numbers? So I have a 3.5 and I have a 0.175 and I'm looking for moles, right? So I should recognize I just multiply them. So moles equals 0.618, 613. Anybody else get that? Okay. But they didn't ask for moles, right? And that's one of those things, by writing this out, hopefully I'll remember. So now all I have to do is change moles into grams. 0.613 moles of H3PO4. And I'm trying to find grams. So if this moles is up here, moles go on the bottom, one goes in front of the mole. I add 3 H's, 4 O's, and 1 P together for my molar mass off the periodic table. And I get somebody. How much? 97? Okay. Anybody else get that? Okay. Oops. And then, so that answer becomes, okay, good. 60.1 if we rounded it correctly. Grams of H3PO4. Whoops, ran out of space there, didn't we? So that kind of covers almost everything. I mean, I might end up having to find liters sometime. Okay, but that's just a procedure that I want you to try to follow. So you've got that other handout with 6 problems on the front, right? Okay, so I want you to work on that. The back side is dilutions. We'll talk about that tomorrow. We're not going to deal with dilutions today. So just do the side. I think it says molarity by mass. Okay, so if you just work on that, that would be fantastic.